class next week on Tuesday. If you are eligible to retest, which means you got below an 85 on a concept, you have to complete the retest review, bring it to class on Tuesday in exchange for a retest. On Tuesday, you'll be doing a special right triangles activity, okay, similar to what we did when we had that scavenger hunt outside, and then people in here will be retesting, okay. You have a new unit packet, okay. Chapter 5 is pretty short, okay. It's only 3 lessons, I believe, and then with some activities, quizzes, and then a test at the end, okay. It is a challenging unit, so make sure that you are being attentive to all the fine little details, and then making sure you're coming into tutorials if at any point during the notes you get lost, because each lesson is going to build on the last, okay? Today we are starting with 45, 45, 90-degree right triangles, okay? We need to review, again, simplifying radicals real quick. Okay, we've already done this earlier in the year when we talked about Pythagorean theorem, but we're just going to recall real quick. For steps to simplifying radicals, we're looking for the largest perfect square that's a factor of the radicand. What is a radicand? The number underneath the radical. Very good. Okay, then you're rewriting the radical as the product of its factors and simplifying. So, for instance, if you have the square root of 8, 4 is the largest perfect square that's going to go in evenly. So it's being rewritten as the square root of 4 times square root of 2. And then you simplify because the square root of 4 is 2, radical 2. You know you're completely simplified when the number underneath the radical no longer has a perfect square factor. Okay, and then you can always double check your factors by typing it into the calculator. So if you type in the square root of 8, okay, it's 2.828, okay, repeating, or not repeating, but keeps going. And then type in 2 radical 2, and make sure that you get the same decimal. That's how you can check to make sure you've simplified your radical correctly, okay. What are our perfect squares? So somebody list them off up until 12 squared. 1, 4, 9, 16, 25.